All right, today we're diving into a really cool research paper that asks us a pretty wild question. What if we could take our mountains of plastic trash and use them to literally build the cities of tomorrow?
I mean, really, think about that for a second. We're talking about taking something that you and I throw away every single day and using it to construct the very foundations of our world. It might sound like something out of a sci-fi movie, but as this research shows, it's actually way closer to reality than you might think. So, to really get why this idea is so brilliant, we first need to understand two enormous and you'd think totally separate problems our planet is dealing with right now. Okay, so on one hand, we have this just mountain of plastic waste. Plastic bottles, as we all know, are a huge environmental headache. They stick around forever, clogging up landfills and polluting our oceans. But on the other hand, we have a scarcity problem. And get this, we're running out of usable sand. A key ingredient for concrete. And that's making construction more and more expensive. So we're drowning in one thing and desperate for another. What do you do?
Well, this is where it gets really clever. The researchers behind this paper looked at these two giant problems and didn't just see a crisis. They saw an opportunity. They had a real aha moment and found a way to connect the dots. And here's their idea, straight from the source. What if we could just take all those plastic bottles, shred them up, and use them to replace some of the sand in our concrete? It's so beautifully simple, isn't it? You take problem A, all this plastic waste, and you use it to help solve problem B, the sand shortage.
Okay, great idea, but how do you actually do it? Let's go behind the scenes, into the lab, and check out the exact recipe they used to cook up this stuff.
All right, first up, ingredient number one, cement. This is the classic stuff, the glue that holds the whole mixture together. Nothing too surprising here. Next, you've got what's called the fine aggregate. Basically, that's just sand. In this case, locally sourced river sand. And this is the crucial ingredient the researchers wanted to try and replace. Then you need your coarse aggregate. That's just a fancy term for gravel, the bigger rocks and stones that give concrete its bulk and strength. And finally, the star of the show, shredded PET plastic. Yep, they literally took used water bottles, cleaned them, and then shredded them into tiny little flakes. This is our trash that's about to become a treasure. So, with the recipe all set, it was time for the most important part, the experiment. Could this new plastic-infused concrete actually hold up? Well, they designed a really solid test to find out. The method here was super clear and straightforward. They made 5 different mixes. First, a standard batch of concrete with 0 plastic. That's our control group. Then they made 4 more batches, each time replacing a bit more sand with that shredded plastic. 2%, 4%, 6%, and 8%. They poured the mixtures into molds, let them cure for 28 days to get good and strong, and then they tried to break them. They tested for 2 key things: compressive strength, how much you can squeeze it, and flexural strength, how much you can bend it before it snaps. And this, my friends, is the moment we've been waiting for. After all that prep, all that waiting, what did the tests actually show? Well, the results were honestly pretty surprising. This is the million-dollar question, right? Your gut tells you that adding flimsy little bits of plastic to super strong concrete has to weaken it. But is that what happened? Nope, not even close. The compressive strength actually increased. Look at this. The bar for normal concrete, the 0% plastic, that's our baseline. But notice what happens when they add the plastic. The strength goes up, hitting its peak right here at the 4% replacement level. It's significantly stronger than the original concrete. Now, after that point, the strength does start to drop off again, but wow. And it wasn't a fluke. They saw the exact same trend when they tested its ability to bend. Again, the mix with 4% plastic could withstand more force than any of the others, including the standard concrete. So it was both stronger and more flexible. That's a huge win. So the key takeaway here is this number, 4%. That was the magic number, the sweet spot where adding plastic waste didn't just work, it actually made the concrete better. Now, this is so much more than just a cool lab result. This discovery could have some really profound implications for how we build our world in the future. Let's just break down the implications. We're talking about a potentially eco-friendly building material that literally turns a waste product into a valuable resource. This could reduce how much we rely on quarrying for sand, which is often really damaging to local ecosystems.
And here's another fascinating detail from the study. Because plastic doesn't soak up water like sand does, it might even help prevent tiny microcracks from forming in the concrete over time. It's a solution that tackles a whole bunch of problems all at once. And all of this leaves us with one final, powerful question. If we can build stronger structures with discarded plastic bottles, what else are we throwing away that might hold the secret to a better, more sustainable future? What other waste is just a resource that we haven't figured out how to use, yet